lights me up. You're the one that lights me up, lights me up. You're the one that lights me up, lights me up. You're the one that lights me up, lights me up. Baby, you're a wizard, wizard. There's magic in your rhythm, like a shockwave to my system. Baby, you're a wizard, wizard. 'Cause every time I'm with you, you're my one and only elixir.
All right. Hello, everyone. Thank you for joining us for today's Isaac Sim office hours. So today we will be focusing on reinforcement learning topics in Isaac Sim, which would include Isaac Gym, Omniverse, Isaac Gym EMS, and then also Orbit. So my name is Kelly, and I'm one of the lead engineers on the reinforcement learning frameworks in Isaac Sim and Omni Isaac Gym EMS library. And joining me today, we have Mayank, who is one of the main engineers for Orbit. So to start things off with, we will first be giving you a brief introduction on the various components of Isaac Sim that are relevant for reinforcement learning, and then we will dive into answering any questions that you might have. So to do reinforcement learning Isaac Sim, the first piece we'll obviously need is, of course, Isaac Sim. So Isaac Sim will act as the main simulator for reinforcement learning. It will provide us with the APIs for interacting with physics, with defining robots, with cloning environments, running the simulation, as well as rendering, and then also providing us with a set of fast vectorized APIs for setting and getting states from physics, which will allow us to do fast paralleled training across thousands of environments when we're doing reinforcement learning. On top of Isaac Sim, we then provide two different tasking frameworks. So the first one is called Omni Isaac Gym EMS, which is publicly available on GitHub, but it's 100% maintained by NVIDIA. So this library contains a variety of reinforcement learning environments that show usage of APIs in Isaac Sim, including simple locomotion tasks like the Mujoko Ant and human learning environment, but as well as more complex dexterous manipulation tasks like the Shadow Hand environment from OpenAI. So this repository is actually modeled after the Isaac Sim EMS repository for those who have used the Isaac Sim preview release, just to simplify the process for anyone who wants to transfer their work over from Isaac Sim preview to Isaac Sim. And with that, I will pass it over to Mayank to talk more about Orbit.
Yes, so as Kelly mentioned, Orbit is like another tasking framework that we have been building now at NVIDIA and other partners of NVIDIA as well, on how we want to really modularize the whole designing of environments in Isaac Sim. So it has a lot of more modular components for designing different rewards, action spaces, observation spaces. A lot more effort has been put into driving this from a configuration management system. And it has a lot of these tasks that is coming from what was prior in Legged Gym. That was like another framework that was built for locomotion for legged robots. And partially all of these now have been moved inside Orbit. And the idea is that this is more of a community-driven platform that is now supported by NVIDIA and partially maintained by NVIDIA, but also more directed towards research and the community so that they start building and making environments on top of Isaac Sim and make like a one-stop solution for everybody who wants to have like a benchmark on top of Isaac Sim simulator.
Cool. I think we can actually open the floor up to any questions. Feel free to post any in the comment section and we'll be able to see them. And
Hey, everybody.
anything like to share?
Well, I would love to. Welcome you both as new hosts of this Isaac Sim series. I have to say, the community has reacted super positively about these office hours. It's a really great service to everybody, and for everybody who's watching right now, this is an excellent opportunity to quiz the experts on Isaac Sim about your project or your any kind of ideas you may have and how this may relate to the workflow that you'd like to do. So we're watching the chat right now. So when you post a question, we will try to hit it right up. I see a few questions popping up right now. Let me see. We got Roboticist asking about Isaac for Windows, Isaac Sim for Windows.
Yeah, it's a great question. So Isaac Sim is actually available on Windows right now. If you go through the Omniverse launcher, you should be able to find Isaac Sim on Windows and download that. And
I love those kind of answers.
Those
what
are
a
the
great
best
way to
kind of
start the
answers.
office hours. Their wish is fulfilled. Okay, Robotics, just let us know. And then the conversation doesn't stop with the office hours here. If you have a follow-up question afterwards, just go to the Discord server to chat with other community users in the Isaac Sim channel. Or for official support with the developers, it's encouraged that you use the Isaac Sim forum. So I'll post a link for that in the chat in just 1 second. But I see you also have another question here from Mohammed. There you go.
Yeah, so how to integrate this particle model in an existing mesh terrain. All the warp examples produces an USDA file to simulate in Sim, but I want this model on top of existing scenes with collisions. So it's actually quite simple in Omniverse to just import USD files into the scene. So even though you might have other items in the scene already, you can always just add a reference to an existing USD file, such as this USDA file that you could get from Warp, and then all of those will be available on your USD stage to work with.
Just to add a bit more, because I think the question maybe here is not just about how to produce the USDA, but if you want to also do it more, like you want to have the interaction between physics, articulation, rigid body simulation with like your own custom particle model that you have in Warp. Currently, the mechanism is similar to what other frameworks like Sapien is trying to do as well with physics and Warp, is that you do like a step of physics, you kind of see what colliders are there, you send that forces model to your Warp model, you do a step of the Warp simulation model, and you send that back into physics. And that's this right now you have to manage on your own, like the stepping of physics and warp sim model that you're building. But eventually, hopefully, this is now gets integrated into one unit inside physics, so you can have more programmable modules. But that's for in the future releases.
Awesome.
Very cool. That's a great question and answer. And I just posted a link for the official Isaac Sim forum. I'll put it on the screen there. If you also just do a search on your browser, you can find it very quickly. But there's the official link. And then I will also go ahead and put the link for the Isaac Sim Discord server or this Omniverse Discord server with the Isaac Sim channel. I'll put that in right now. Actually, what's good? One thing. Oh, I'll let you answer this first, and I have another question afterwards.
Mac, do you want to take this one?
Yeah. So the question is if there's a ETA or what's the ETA for Orbit release to happen? So the Orbit code, at least, it's on Devil, and that's mostly ready from the API side point of view. We are working mostly on the docs part of this now so that we can merge this to main and then everything gets ready. The timeline for this, at least for us, is mostly going to be synchronized with the upcoming 2023.1.1 release, which should be happening this week or in the next week. So hopefully, but if people want to start using it already with 2023.1 API wise, it should now already be working and people can start trying it out at least.
And we've been alternating office hours between Isaac Ross and Isaac Sim. This week, obviously, we're doing Isaac Sim today. Next week, we Ross. Can you guys just give an overview of what Ross is and why Sim and Ross are not the same thing?
Do you want to go for it, Mike?
Yeah, I can take a stab at this one. So I think there are different components when it comes to robotics applications, and I think it's a very big field that we are working in because you have a lot of people who want to do a lot of cool simulation stuff. A lot of people want to do a lot of more hardware deployment related things and a lot more on the learning side of things. So there's like a very different needs of the community, and it's also like there was like 3 different, say, major focuses at NVIDIA on the simulation side of things. So one is, of course, the Isaac Sim, which is really about how Omniverse can be connected for robotics applications. And there it's mainly about providing APIs that you can get all the data that you need for sensor simulation, for getting the physics data that's happening in the back, and having a nice set of APIs that are agnostic to all the internal nitty-gritties of how the Omniverse is doing these things. Isaac Ross, data is now communicated over the ROS TCP protocol, ROS 1 or ROS 2 protocols of message passing, because that's how we normally work on the robot stacks. That's where all the processes are running as different all the nodes are running as different process on your computer, and you want to get the data from the simulator that is streamed, similar to what Gazebo and ROS in relation has. That's Isaac Ross is kind of trying to also build this gap that you can have a nice simulation and you get all the sensory data and setting your commands back into the simulation, and that's the main focus. And the same side, we have the Isaac Gym, the Omni Isaac Gym ends and Orbit, which is again using the same Isaac Sim data that you're getting, the data you're getting from Isaac Sim, but now really targeting this more towards learning-based applications. And these are like the 3 different, let's say, components of how all this works. And it's like the overview of how these are set it up. And maybe Kelly, if I'm missing something, you can also add here to this.
I think that covers it pretty well. So Isaac Sim is more on just the overall simulation side, but Ross will actually let you communicate through this protocol to interact between your simulation and the real world.
And does ROS stands for Robotics Operating System? Is that right?
Robot operating systems. Yeah.
Robot, of course. And it'd be great. So people watching either live or watching afterwards, because this video will live on our YouTube playlist for Isaac Sim. If you'd like to share your project, that would be something great. We'd invite you to come on a future live stream and show off your project and talk with some of the experts, share with the community, get some feedback. We would love to show off your real world use of how you're leveraging the technology. And for those who are just getting started with Isaac Sim, maybe they kind of are watching Isaac Sim office hours for the first time. What do you suggest for people to get started first? And what level of kind of experience do they need to have to start working with Isaac Sim?
So I think the best place to start with is probably the documentation for Isaac Sim. So it gives a very nice overview of what Isaac Sim is and what the components available in Isaac Sim are. And also it gives you some of the hardware requirements. So what kind of hardware you actually need to install Isaac Sim and then run the different various Isaac Sim components. And then if you go more into details of the Isaac Sim docs, it also goes into the different aspects of Isaac Sim. So for example, we have a section on GIM for reinforcement learning, which gives some nice tutorials on how to set up your first reinforcement learning task. A nice tutorial that walks through a simple cartpole example of how you can actually implement that with Isaac Sim. And then more advanced examples on how you can actually create your own reinforcement learning environment. And in addition to that, the Omni Isaac Gem EMS framework and also Orbit both provide their own documentation as well, which will actually help you get started on the individual frameworks of your choice.
Very cool. I just popped everyone's name on the screen so everybody knows who's who. And then I forgot we have a nice Isaac Sim banner for this series. So there you go. So people just tuning in will know exactly what we're talking about. Very cool. And in terms of experience level, like we've seen there are a lot of high school programs actually doing robotics also. Have you seen high school students work with Isaac Sim?
I think we have. Yeah, we've definitely had a nice variety of audiences for the Isaac Sim tool. Seems like people are starting programming at a young age now, which is great to see. But yeah, it's definitely open to any level experience. Obviously, having some experience programming with Python would definitely be helpful. For reinforcement learning, most of the scripts would be Python based. But again, there are a lot of nice tutorials that can help you get started, even if it's something new for you. And of course, we now have the awesome ChatGPT that we can use to help you with anything that you might need.
Yeah, and I know there's a Chat USD that's in development, which will even go further, actually, to help people leverage that model. We have a question here from the Blue Dot. So I wonder if this is this is Planet Earth asking us this question. There you go. I was playing around with a Carter V1 robot. I found the physics breaks when I moved center of mass of base link a bit further on the x-axis. Have you guys seen that before?
That's an interesting question. I can't say I've personally worked with the Carter robot, so it's hard for me to say what might be going on, but perhaps it's something related to the physics setup. So I found that the physics simulation might be quite sensitive to the way that robots have been set up. So maybe moving the center of mass slightly might actually be interfering with something in the physics simulation that it doesn't like. But I
think it would be interesting to bring this up on the NVIDIA on the forums itself, so that then we can have more information on what exactly are examples you're picking up on and what's happening there, and then we can maybe discuss this more with the physics team as well, because they would be, I think it's more of a question of how physics and Omniverse is handling this.
We also on the Omniverse Discord server, which I mentioned earlier, easy to get to, discord.gg/NVIDIA Omniverse. We actually also have, in addition to Isaac Sim channel, have a physics channel where we have actually Omniverse developers hang out there a lot. So if you want to ask some tough questions on to the physics developers, they're very responsive there, and they also have an official forum, but they also hang out on Discord. So great place to go if you have physics questions. I see a couple other questions rolling in. You guys have there you go.
Yeah. So previously I used rotating LiDAR physics to get the point cloud on my RL environment at Isaac Sim, which worked well in 2022, but not in 2023. The error message says LiDAR sensor does not exist. So I think one common problem that might be the cause of this is in 2023, we actually cleaned up a lot of our extension dependencies for the GIM RL side. And the main reason behind this is for performance reasons. So as the more extension dependencies we have for GIM, the longer it will take for all of the GIM environments to start up. And we know that the startup time has been an issue for a lot of users. So from 2022 to 2023, we actually did a major cleanup of our dependencies, which might have removed this rotating LiDAR physics dependency that was available in 2022. So an easy fix for this is you can actually just go into the app file. So there are .kit files inside the apps folder in Isaac Sim. Just find the one that's being used for GIM, and then you can add in the additional dependency there for the extension that's required.
So also just to add on to this, it could also be that since the rotating LiDAR was using physics, we had like a new one that came out in 2022.2.1, which was the RTX LiDAR implementation. And we would need to double check this, but I think it could be that the physics one was deprecated in favor of the RTX LiDAR implementation, because that one has better realism of how actual rendering works, and it can also mimic the effects of how LiDAR arrays will behave when you have transparent objects and all these kind of things. So it should be, I would double check this if there's a rotating LiDAR RTX that you should anyway you should move on to, because it also should be a nicer implementation of these features.
I think we have another question down here. Is there any plans for implementing the GPU version of the RMP flow? If yes, is there an ETA for this? I'm not too sure about this actually. Mark, do you know anything about this?
I think there was some work that are happening in Cortex, on Isaac Cortex side, of how to get the GPU implementation of RMP flow. To be frank, I don't have a very strong idea what's the timeline for this right now. But if you check, recently NVIDIA Research also released like this library called QRobo, which is CUDA accelerated. There's library for CUDA accelerated robot controllers. And it might be worth taking a look if you want to have more task-based controllers, if that actually fits the need, because that's exactly what they were trying to go for, which is, but I would definitely check that out. And yeah, we will probably have another notice on when the GPU implementation of RMP flow itself comes into existence.
Yeah, I've definitely heard discussions around implementing the GPU version of RMP flow, so perhaps it's in the works, but we just don't know the details at this time. All right, another question from Mohammed. Do I need a RTX-based GPU to run Sim headless as well? Yes, I believe you do. So at the moment, any Isaac Sim application will actually require an RTX-based GPU, whether you run headless or with the viewer. This is a requirement of Isaac Sim. Another question here. Can we make an RTX LiDAR in our own graph without running the script? It's an interesting question.
I think
Maya,
this
you know
is
the
a
answer?
bit beyond what we have been working on, because we haven't been doing so much of this work on the graph side, at least from the RL point of view or the learning point of view. But this might be something that's more interesting to bring up another, like office hours, where you have the more expertise on this domain coming in there.
Yeah, and I think the Isaac Sim forum might be a good place to ask this question, and perhaps others have tried doing something similar and they can share their experience as well. How do you add icons to an OmniGraph node in 2023.1? I think this might be a good question for our OmniGraph team. I'm sure they have their forums for support. I think the experts there will probably be able to help you out much more than what we can answer here.
Also, we had that question earlier from Sirens. He's actually doing a really cool project right now. And additionally, he has recently done a ChatGPT for Isaac. And Sirens, why don't you go ahead? I'll find it in a second. But if you have it next to you, why don't you post a link for that in the chat? I think it's a really cool resource. We love when we see the community doing really helpful things like this for other users. So feel free to post that link in there so others can benefit from the great chat app you created.
That's awesome. It's great to hear. It would be very helpful to have a ChatGPT tool for Isaac Sim.
I think we missed a question from Robotics earlier, which was they were unable to find Isaac Sim in Omniverse exchange. I think Kelly, you can maybe elaborate a bit of how things have now moved from Isaac Sim to Isaac Sim a bit.
Yeah. So we've released something that we call the Isaac Sim preview release. So this was a standalone tool that was not based on the Omniverse platform, but it was designed to provide the same set of vectorized GPU-based APIs that allows for interaction between your robots and the physics states. So since NVIDIA's focus have kind of shifted towards Omniverse, we've also shifted all the APIs that we had available in the Isaac Sim preview release into Isaac Sim. And so most of NVIDIA's focus is on Isaac Sim right now, which it uses the same physics SDK at the back end for our physics simulation. And it also provides the same set of vectorized GPU APIs that we can use to interact with physics. So Isaac Sim is available on Windows. Isaac Sim preview release is Linux only. And for the long-term roadmap, we don't have plans to continue support for the preview release, since most of our focus has shifted to Isaac Sim. So we do actually encourage people to try out Isaac Sim and let us know what your thoughts are, and we will also continue to improve on what we have in Isaac Sim and also the RL frameworks on top of that.
Okay, I just found that link from Scott Dempsey, so I'm going to go ahead and put in the chat. Let me see. This whole thing fits. I'm gonna shorten this a little bit so it fits. Let me see if this works. Hopefully that whole link came through for everybody. But there you go. That's from Scott Dempsey, aka Sirens, who's just posted that question in the chat a few minutes ago. There's a link for his chat bot for Isaac Sim. You are very well. Thank you, Scott. Appreciate it.
Awesome. Okay, we have another question here. I'm trying to get point cloud data on the RL environment. Is using Replicator a good alternative?
So actually, it depends quite a bit on what you're exactly trying to do. So I can speak a bit more on what we have been doing in Orbit on this side. So Replicator is quite good, and the whole Isaac Sim, they are providing this point cloud data that mostly gets piped through Replicator APIs for data generation. And that's quite amazing if you have like dynamic scenes and that's what you're focused on. But if you have like simple static scenes, then you can also do your own raycasting operations or define your own raycasting operations through Warp. That's also like an example that now exists in Orbit, where for the locomotion environments, we have like these elevation maps or height scans that are basically happening through the raycast kernels that we have implemented. And if that's what your use case is, and maybe it's worth taking a look into Orbit and how this is being done there. And if you have questions, we can also discuss this there.
Yeah, and we're also working on depth rendering as well in Isaac Sim. So if that's something that you're interested in, definitely keep an eye out for future releases that should have that feature available.
Yes. I think there are 2 more questions.
Yeah.
So if it's possible to integrate camera images, yes. So there are 2 camera implementations. One, like I said before, was the USD camera, which is again using Replicator for synthetic data generation. And that gives you all the images in a batch format. And then this other one is like a warp camera, which is like a more simplified camera implementation, at least right now, as a intermediate for learning. If you have static scenes, that works quite nicely. So yeah, there are these 2 options that exist in there. And hopefully as we improve Isaac Sim, we add more parallelized camera simulation in there. All these things will also improve and you will have higher perf rate that comes out of it. So just putting in numbers right now with the RTX rendering for cameras, at least with 2023.1.0, we get around 100 FPS if you have 8 to 10 cameras, but I think for like a more involved scene with like a Franco robot doing something. And I think Kelly also had posted like an initial version of now what will be the parallelized camera rendering. It's there in OIG for Cardpool, where I think she had like also like a better improvement. So things are moving quite fast now at NVIDIA, and hopefully we get more and more of these technologies in there so we can start using them a lot more for higher throughput for learning.
Yeah, so since the 2023.1.0 release, Isaac Sim, we now have a somewhat parallel version of the rendering API that's available in PyTorch. So the number of environments you can run with this, it's still relatively limited at the moment. So right now, I think you can get somewhere around 32 environments running in parallel with camera training as using vision as using images as observations. But we are looking at improving that limitation. And of course, our goal is for you to be able to do vision training with thousands of environments in parallel as well. And another question here, can we do 3D terrain generation instead of just 2D planes? Right now, I have to do 3D undulating terrain generation in Blender and then import the USD in Isaac. So yeah, I believe both the Omni Isaac Gem EMS framework and Orbit provide terrain generation tools. So I can speak for Omni Isaac Gem EMS, where we do have utility tools to generate different forms of terrains. And you can specify the parameters of the terrains so that we can randomly sample based on the parameters that are provided as input. And the output of these terrain generation tools will then actually be 3D terrains that contain 3D meshes that are directly in USD. So you can skip the generation part in Blender and then having to import into USD. So one example that we do use the 3D terrain generator is the animal terrain example. So if you take a look at the video of that environment, you can actually see the animal robots running on different forms of terrains. And all of those are actually procedurally generated with this terrain generation tool.
Scott, asking about a connector. Scott, do you want to just a connector for which part? Sorry, for you to clarify in the comments. Or Scott, also, if your camera ready, I could also send you a link if you want to join us here, so you can chat with the dev live. Blender connector. Okay, yeah. So there are so Blender obviously is an amazing DCC. It's free to everybody. The features being added regularly are just mind blowing. It's a great product. There are two different ways you can get Blender. You can get Blender directly from the Blender website. You could also get it from within the Omniverse launcher. The Omniverse launcher version of Blender has better support for OpenUSD. So, but both you can work with both, but a little easier to work in the Omniverse version. So you can go ahead and download that Blender version right from the launcher. Yeah, the Captain has joined. Hey, Captain, nice to see you in the chat. Great to see these great big Omniverse fans joining these chats. Feel free to post your questions. Looks like he hasn't done his hair yet. That's okay. Maybe next time. Actually, we're gonna have Scott on a future live stream. Probably on one of the ones we do at 11 a.m. Pacific on Wednesdays, the ecosystem ones. Like I said earlier, he's doing a great project, and we'll maybe have him do a little show and tell. But yeah, if you have any questions right now, you're watching, please feel free to post your question in the chat. We're a little over halfway through this edition of the office hours for Isaac Sim. We're focusing on Orbit and Jim right now, as the description states. If you have any other questions, we'll try to answer them here. But otherwise, official forums of the Omniverse Discord server to chat with other users is a great place to go. Also. What do we have coming up? In terms of any main features or kind of any big updates that the people users should know about look forward to? Anything, without giving away any dates or anything, kind of what's on the roadmap? Anything people should be aware of and can be excited about?
Yeah, so we actually have a new Isaac Sim release that's planned out to come out very soon, possibly next week, but definitely before the end of the year. So anyone interested, definitely keep an eye out for that. Along with that, we will also have the Omni Isaac Gem M's repo update to sync up with the latest Isaac Sim. And I believe Orbit is also planning a upcoming release as well.
Very cool. That's exciting. And what would be the main things that are going to be coming in the new update that we can share? Relating to Isaac Sim, I guess.
Yeah, so I think for this release, we were really focusing on ironing out any of the bugs that were reported since our last release. So we've had some great comments from our forums and our GitHub issues that were bringing up different bugs that people have discovered. So we've been working hard to fix out all of those bugs so that we can provide a better experience for everyone in the upcoming release.
Awesome. And as we're talking, I saw another couple questions and comments come in. Feel free to pick one of those.
So I'm trying to fuse particle model coded in Warp with animal terrain. And eventually try to train RL policy. And the second part of the question is making USCA from Warp and adding, or is there a way to do it on code level, or should I look into visual scripting as well?
So I think this you should directly be able to do by just having a warp sim model running in parallel of your physics sim model and just transferring forces between each other. Or if I understand this correctly, if that's what you're trying to do, then it should be possible to just get that data from warp, apply it on physics, get the data from physics, apply that back to warp. But for a more thorough, you need to maybe explain a bit more on how exactly things are being done there. But that's how at least we have been trying this out within our collaborators on how to do this integration with Isaac Sim.
All right, and we have a question here. Are there plans for implementing GEM via OmniGraph? I don't think we have this on our roadmap at the moment on the Omni Isaac Gem M's side. I'm not sure, Mayank, if you have any plans for Orbit regarding OmniGraph.
So far, no. Currently, there isn't this straightforward plan yet to integrate this into OmniGraph. I think that's something we have been discussing quite a bit internally of how we can make this happen. I think there are definitely some concerns with it, but that we're trying to iron out and just make sure when we do this, it's like a lot thorougher, because although the whole MDP design sounds like a very structured way of doing things, it's kind of hard because things start depending on each other quite quickly. Like your rewards depend on what your actions are. Your observations might also depends on what things are going on. Randomization depends on curriculum. So all the different modules start talking to each other, and then this graph becomes more and more cyclic in nature. So we still need to figure out how this will actually end up, and what level of APIs can actually be made around doing learning with OmniGraphs.
Sounds good. Less memory leaks. Hopefully, yes. So we definitely discovered many sources of memory leaks internally, and we have found fixes for some. We're working on others. So yes, of course, the goal is to have zero memory leak. But if you do run into issues, definitely report it on the forums or on the GitHub issues, and we will take a look at it.
It was a great story that was published last week that Captain just mentioned in the chat. Here it is. Here's his comment here. The Amazon Adobe example was amazing. So I just posted the link to that great article on Adobe's website. And I apologize. Sometimes when I post the links, they're a little long, so they get on YouTube, they get split up into 2 comments. So I'll just copy and paste them to combine them into one URL, and it should work okay. But that is a fantastic article, and really shows how leveraging USD and these varying technologies from great companies allows people to work together and do amazing things, like very complicated things like warehouse operations in the Amazon Robotics case. A very cool article. So thanks for mentioning that, Captain. Okay, we still got some time left. Oh, go ahead.
Yeah, there was a comment very, very early on. Are we going to do a demo? I don't think we actually planned on doing a demo. But if we have some time right now, perhaps that's something that we can look at.
That's one of the great things about a live stream. Anything's possible. Yeah. So if either one of you want to share your screen, that I think that'd be great.
Yeah. So let me just get things set up here, and then we can maybe do a quick demo.
While Kelly's bringing that up, also give a quick mention of an exciting event that's happening. Well, there's a couple exciting events happening. Later on today, actually, at 11 a.m. Pacific, we're going to be doing a live stream that's focused on Foundry Nuke and how you can leverage the latest features there for amazing compositing. We're going to have one of the developers on our team talk about how he used it to do DaVinci Workshop scene. If you have seen it online, it's pretty beautiful, breathtaking, actually. So we'll be showing that workflow along with some developers from the Amazon, Foundry Nuke team. And then obviously we have GTC coming up in March, our first in-person GTC in years. And we hope everyone can, if you can't make it, we hope you tune into some of the virtual stuff we'll be doing supporting it. But if you can come in person, a lot of members of our team will be there and we can set up meetings and discuss your projects and help. Feel free to reach out to me or anyone else in the community team. We'll help set something that up. My email is pretty easy, edmar@nvidia.com. You can also hit me up on Discord if you go to the Omniverse Discord server. And there we go. Whoa, we're in the multiverse now. All right, here we go.
All right, hope that's better.
And then finally, before Kelly starts on this show and tell, the GTC website is super easy, nvidia.com/GTC, and that'll show you all the stuff we got planning, and the sessions will be coming up any day now. Okay, take it away, Kelly.
Awesome. All right. So just to give a very cool short demo, this is something that we've introduced in the last Isaac Sim release. It's something that we call the extension workflow, which is available in Omni Isaac Gem EMS right now. And what we can do with this is actually we provide a UI that lets you launch any reinforcement learning examples. So here in this UI, we can actually have a list of all of the RL environments that we have available in Omni Isaac Gem EMS. And we can select any of these here and just load the scene through the UI. So you can actually do this without having to write any Python scripts or launch any command line commands, and just navigate through everything in the UI. So once we have our environment loaded, we can actually just start training here with the start button. And we can see on the terminal window on the left that things are actually running. And so right now we have something that we're running called the full rendering mode. So we can see that all of our environments are rendering at the same time. Obviously, that's going to eat up some of the performance. So we could actually switch between the modes here. So we can render only our UI, but not the viewport. And we can see that things are actually go a lot faster. And once you see that, your work has been going up and you're very satisfied, we can actually go back to our full rendering mode and just check out what our environments look like. So now it looks like, our corpos are actually training quite well. Seems like they're doing things the way that we want them to be. So we can actually stop our training and simulation by just clicking on this stop button. And then from there, we can also just do inferencing. So if we want to check out inferencing on the policy that we just trained, we can check this test button, and then we can just start again. And this will actually be running inferencing on the policy that was just trained a few seconds ago. And then the cool thing about this is you can actually just switch between the environments. So if you don't want to work with Carpo anymore, but instead you want to work with a different environment, we can actually just choose a new one from the drop down here, and then just reload the environment by clicking on this load button. And now we can see that we have our Ant available in our screen here. And if you just want to do training again on our Ant environment, we can then just click start again, and then that will start training your new environment.
Wow, a lot of happy people in the chat right now looking at this on the screen. It's Scott, that's sick. Very cool. And then we had a question from Zia Ideas, who's an amazing member of the community, and I believe will be on our live stream later today, actually, because he's going to show off some nuke stuff. So if you've ever seen Zia Ideas in the flesh, you'll have a chance in a few hours. Okay, how do we designate the number of robots cart poles to test on environments?
So yeah, if you there is a UI in that extension workflow that I just showed. It's a slider of numerical value, so you can actually drag the slider or just input a number in there, which will specify the number of environments. So when we're doing the testing, sometimes you can just put a smaller number, like 5 environments or 10 environments. So you would just enter 5 or 10 inside that slider, and then just click on load, which will then reload the scene with just 5 environments or 10 environments for your cart pole.
Very cool. You got a follow-up question there. How hard is it to load custom 3D models?
That's a great question. So custom 3D models, it depends on the format, I would say. So if your 3D models are in like OBJ files or any other kind of 3D file formats, I believe Omniverse has a great selection of importers that will let you actually import 3D models of different file formats into USD. And then once you have your 3D model in USD, it becomes very simple to add it into your USD stage through either the USD API, or in the UI, you can just drag and drop into your current stage, which will then load in your 3D model in the stage. So yeah, it really depends on the format of the 3D model. If it's already in USD, then that's great. You can just work with it directly through the USD APIs.
Very cool. Thank you, Zia, for that great question, as always. Okay, cool. Let me see. Any questions? There's these final minutes of the office hours. Feel free to post them in the chat. And I also posted in the link in the chat our calendar for upcoming live streams. I believe Ross is happening next week at the same time and place. I mentioned we're doing nuclear related today. We also have a really cool session related to SIGGRAPH Asia next week on Monday at 3 p.m. Pacific. It's Ask the Experts with some USD experts, including Aaron Luck, who's been producing that amazing USD series on our YouTube channel. Maddie will be there also from our team, along with several members from other companies. So we hope, I believe someone from Animal Logic will be there. And am I correct? Yeah, and folks from Weta. So next Monday, amazing live stream happening. That's on the calendar I posted a few minutes ago. Very easy to actually add different events from that calendar onto your own calendar using that link. Okay, cool. So do you guys have any final comments before we close out the stream in a couple minutes?
Maybe we can also give a demo on Orbit if that's
yes,
here.
that would be awesome.
Missed out on that part.
All right, cool.
Try to see if I can share my screen.
Awesome. Well, Manic does that. Remember the GTC website, nvidia.com/GTC. I pasted the link. I believe that link is a little discount, and here we go.
So we have like a humanoid environment in Orbit here with procedural terrain generation, as you can see. So there's like a small GUI that we have here with different rendering options, and you kind of can go over which environments you want to work on, and then you have different options like whether you want to follow the robot while it's walking around and doing something, and like you can see, this was like something we trained in Orbit now, and you have like this Unitary H1 that's just walking around in the environment that we trained in, and you can just drag it around to see how robust the RL policy itself is. And this is something we trained with RSL RL, and it works quite nicely. You can see, like, of course, if you apply too much force, it falls down, but when you make it stand up again here, it starts walking again, which is like really the beauty of RL here that makes it so robust to these things. And then like we showed in the past with Lego Gym, you have all these different procedural terrains that you can make with different pyramids and different noise models as well, and do all these kind of cool maneuvers. So of course, it's quite a lot of their locomotion examples, but beyond this, once you check it out, there are also a lot more manipulation examples for tabletop manipulation as well as mobile manipulation setup. And there the emphasis is a lot more that it's not just one robot that we designed environments for, but let's say we designed this environment initially for animals. It's one of the robots we also work on quite a lot with. But the same environment we now use for training a humanoid or other quadrupeds that are out there. And like now we kind of show here, let's say what these UI operations does. So let's say this one is now following the robot on this environment index over here. And you can just go over each environment index and just set your camera view and make some nice videos, and also toggle things like what's the sensor visualization is over here, and all these like small details that really make it nice for doing debugging with this with the framework itself. And of course, this is like just one demo that we trained with RL, but there's a lot more other support for other libraries like RL games, stable baselines, SKRL, and we're open to also community sending in all more merge requests or feature requests as well, and what kind of libraries and what kind of environments they would like to see in there, and to have like this whole exchange from what you guys would like to see in Orbit, and how we can actually make this grow together as a platform that we build, as an application we build on top of Isaac Sim itself. So yeah, I would maybe pause my screen here for this and take in any questions.
It's wild. We've got one question from Zia about the hardware.
What kind of hardware are you running on? What is a minimum hardware spec for training? That's actually a great question. So the demo that I was doing was running on an NVIDIA RTX 3500 laptop with 32 gigs of RAM. So I would recommend for most reinforcement learning environments to have at least around 32 gigs of RAM, and then a GPU, I would say, with at least probably 12 gigs of VRAM to just have a smooth experience for the reinforcement learning environments. Mike,
Mike,
do
did
you
you want
want
me
to
to share
share
your
this
screen? I'm sorry, Mike. Did you want me to share your screen? I see it at the bottom there.
Oh,
No? Okay.
no,
I
sorry.
just wanted to make sure I wasn't missing anything. Sorry, Kelly.
No worries.
Another nice comment from Sirens there. And we have the hardware requirements are pasted in the chat now. And we'll post some of these links in the description afterwards. We do the timestamps. Oh, okay. Here's all right. What would you guys say to this? No budget limit.
CPU, GPU recommended, no budget limit. Go wild, I would say. I don't know, get a server or something.
Yeah, sky's the limit, right? Especially with access to cloud. There you go.
Yeah, exactly. Go for a hopper. Yeah.
So I think it's a bit. I think one of these things also depends on what you exactly want to go for. Eventually, if you want to do more perception-based stuff, you really want to kind of go up, have more VRAM in your GPU side. A lot of our a lot of partners, I think, are also using like all variations of this, like still a 2080 RTX all the way to now 4090s, which are more PC grade, but also going more on the cluster side of A100s and above. So it depends like what kind of setup you want to go with and what kind of applications you have. So if you ask no budget, then of course you just max out whatever is the capabilities of your motherboard over here. Have like 3-4 GPUs or whatever you can. But on a more realistic side, I would say for at least what are kind of testing, or like what kind of PCs we normally are testing with as well. It is more on the consumer grade side. It's like PC at least like 64 gigs RAM, a nice CPU as well, because it still is quite important to have that for a lot of the threading that happens internally. And at least go for like something that's 3080 and above if you want to have a more long-term usage. It's not just a one-time purchase for this.
Yeah, and for those who don't want to set up your own PC, there's always the option to run in the cloud as well. So we do have training available. You can set it up on AWS or GCP. So cloud services are supported as well.
Cool. A lot of cool comments coming in, different suggestions for different setups. I won't put them on the screen, but there's a nice variety there in the chat. Here we go. Another quite good question from Joker.
A100, H100 work with Isaac Sim in any way. I thought they don't have any RT cores, which is a requirement. Not too sure. I believe A100s do work. I think we have tested it before on the cloud server. It might have just not been with rendering, but I believe it should be possible to run A100 with Isaac Sim.
And feel
But
free
we can
to
double
search
confirm that.
I was going to suggest feel free to search the forums too on that question,
Mhm.
A100 and the Isaac Sim, and I bet you'll see some feedback on that right away. And if you don't, feel free to reach out to us and we'll follow up with you on it.
Cool. I think if no more questions, we can maybe wrap it up there.
I think it's been a very, very insightful, exciting hour. You guys did a great job on your first office hours live stream together. Really great to see all these great questions coming in. And as we said earlier, these live streams are happening every week now for Isaac. So either alternating between Isaac Sim and Isaac Ross. Next week will be Ross. We'll also have a lot of stuff going on the calendar for live stream. So check out the calendar link I posted earlier. The next one is same day, same time next week will be Isaac Ross. I'm just answering a question from Guanbin Huang right there. Also, be cool. Next time, let us know where you guys are and girls are watching from. Be cool to see where everybody is connected from across the world. But really, really great to see everybody here on the live stream. Thank you so much, Kelly and Mayank. I think it was really helpful to have you here with the office hours, and thanks for the demos. Really appreciate it.
Great. Yeah. Thank you everyone for joining. It was great to see all of your comments.
Bye, everybody. Have a great day.
Bye.